A very good evening, everyone. I am Sai Kirtana Bandreddy, Publicity in charge of Access 2022. On behalf of the institution, I would like to extend a warm welcome to everyone attending today's online lecture. We have the distinct honor of introducing Dr. Madhulika Guhathakurta, citizen scientist and works as Heliophysics at NASA headquarters. Her whole life has been dedicated to studying the sun. Over the past 2 decades, her groundbreaking work has advanced our knowledge of the sun and space weather events. She has a long-standing experience and interest in eclipses and has led teams to observe 11 total solar eclipses worldwide. She is currently breaking new ground by integrating artificial intelligence and machine learning to better comprehend the solar cycles. This lecture will provide an overview of her career. We are very delighted to have you among us, ma'am. Over to you, ma'am.
Thank you very much, Sai Kirtana, for your persistence in getting me to do this. Should I just get started? I am delighted to be here and help you, at least take you on a ride with me. So if you think it's time, I can start sharing my screen.
Yes, ma'am, you can start, please.
Just wanted to tell in the beginning that, since this is kind of much more of a interactive and fun talk, I'm not giving this talk on behalf of NASA, but as a citizen scientist trying to communicate, some of the things I have done and what my thoughts are. So let's kind of get started right at the very beginning. Most of my talks will typically start with, facts, figures, and charts, which we all know are boring, more so when they are about something as cool as our universe. And so, what I'm going to do is I'm going to fill this talk. I'll take the poetic liberty to utilize as much as possible pictures, cartoons, and poems to bring to you at least my journey. And talking about poetry, I would definitely like to recite one. And this is by Walt Whitman. When I heard the learned astronomer. When I heard the learned astronomer, when the proofs, the figures were ranged in columns before me, when I was shown the charts and diagrams to add, divide, and measure them, when I sitting heard the astronomer where he lectured with much applause in the lecture room. How soon, unaccountable, I became tired and sick, till rising and gliding out, I wandered off by myself in the mystical, moist night air, and from time to time, looked up in perfect silence at the stars. Yes, it is a poem by Whitman, but many of us have felt this, haven't we? Sitting sometimes in dreary, dull, boring classes, but we still have to learn. No escape from that. So, this has always been the case, right? With presenting our thoughts on something so vast, so expansive. So let's not confine ourselves, as I say, to facts and figures. Let's hear out instead, my letter to the sun in the form of my journey. And it began like with anything else, with questions. Dear son, I want to ask you a few questions. They might be tough, but only you can answer them. Do tell me. And the questions are as basic and as universal as, where have we come from? Where do we go when we die? Where indeed a question humankind still ponders, and I'm sure all of you do too. These are tough questions, aren't they? So don't ignore me, son. I know they're tough questions. When I was very young in Kolkata, I used to watch the night sky. As I looked at your siblings, the other stars, I had the same questions. So I asked my father. My father, being who he was, both a mathematician and a philosopher, drew a circle for me and he said, look at the circle. Can you tell me, where the beginning or end is? So in a way, he answered my question with another question. But through my formative years, I came to notice and learn a few things that's about life in general, which helped me really understand my father's point better. He didn't stop my curiosity. No, it is our biological wiring, right, to exist and then someday not. Through our lives, we find our loved ones. Through our lives, we keep on working, moving. And the loved ones, never mind the species. We do, no matter which animal kingdom we belong to. Through our lives, we build homes, we break them, we rebuild them, but that's what we do. And then one day, disband and return to the aloof stars that made us in the very first place. Pretty deep stuff, right? What I want to show you here is this iconic picture taken by Voyager 1 spacecraft in February of 14th, 1990. I don't believe any of you were born. I'm imagining I'm talking to people who are in college, right? And I want to point, this is called the pale blue dot picture. This is the sun when Voyager spacecraft traversing through the solar system look back to take a picture of our tiny home. This is so profound. This deserves a recitation of another poem, I would say. And it's a poem by Maya Angelou, a brave and startling truth. We, these people on a small and lonely planet, traveling through casual space, past aloof stars across the way of indifferent suns, to a destination where all signs tell us it is possible and imperative that we learn a brave and startling truth. And it is for each one of us to find that out. So I understood that if we came from the stars, going through some school and college, of course, and that to the stars we return. But my curiosity about our existence was really unbridled, and hundreds of questions were squeezing together in my young mind, much like the atoms of elements squeezing together, in dust clouds, thus undergoing what's called fusion and birthing a star. Now, how are we related to the stars? Oh, good question. And we have made significant progress on that. This is really about star life through my journey Again, in school and college, I came to understand a star's life is long compared to that of a human, but we can see the stages of stellar birth, aging, and death in the heavens. They follow a pattern similar to many of the life cycles we see here on Earth. And I came to understand, and then kind of with that knowledge, what has always struck me is that human beings kind of tend to think in binary form, 0 or 1 in computer, yes or no. Otherwise, right, there's like not much room for gray. Either we are superior to nature or we are inferior to it. And I came to understand that we are neither. Our place in the cosmic order is not something that is separate from nature, but is an integral part of nature itself. Let's continue to explore this idea, right? The human body contains around 20 different elements, mostly made inside ancient stars. The main 4, you all know: oxygen, carbon, hydrogen, and nitrogen. So for every atom belonging to me as good as belongs to you, remember? So stars hold the answer to our existence. And the only star that can help us answer these questions, the only one which is near us, gives us the opportunity to ask this question in the first place, is our very own star. Hence, my letter to the sun. So if I was going to get my answers, that's what I'm going to do by studying you, the sun. Now, my story might sound like a cliche, right? It revolves around the sun. But isn't that true for all of us? I mean, what is a birthday after all? Another revolution of a person on planet Earth around the sun? You attracted me, sun, and falling prey to your immense gravity and charm in the form of magnetic energy, I made a career out of you and the other stars to find my answers. And then, of course, I get into the real star stuff, right? I get to do some of that myself. So I joined NASA in 1993 as an astrophysicist and have had the opportunity to work as a scientist, a mission designer, an instrument builder, and I directed and managed lots of science programs and missions. A wonderful thing about working there, among so many others, would be really the privilege to see and know things about our universe, which not many others are privy to. The unthinkable imagery that we collect every day, every minute, every second, and the new science findings which we witness every day changes a person. And from this newfound knowledge and inspiration, I understood how learning about our sun would not only help us contextualize our existence, but also help continue our existence into the future. Now, you may ask, how is understanding the sun going to help us, right? Well, I mean, for one, if you don't understand, the one who birthed us might get angry one day and take its gifts away in a single moment. Now, of course, I'm joking, but not completely. And the question is how? Of course, the answer is solar storms. Yes, like on Earth, we have hurricanes and snowstorms. On the sun, we also have solar storm. The sun produces flares and coronal mass ejections, except these storms consist of charged particles. A solar storm is a disturbance on the sun which can propagate outward across the heliosphere, affecting the entire solar system, including Earth. and its magnetosphere, and is the very cause of space weather. And coronal mass ejections is one of those really humongous events. Excuse me for a second. These coronal mass ejections, they consist of billions of tons of superheated charged particles, and you're seeing their explosion from the surface of the sun shooting off and hurtling 93 million miles. That is the distance between sun and earth. And when they hit Earth's magnetic field, they trigger geomagnetic storms, which can really cripple us, our technology, basically. And these storms are caused by regions of intense magnetic energy. If you actually went to some of our websites, you will see that there is such a massive explosion that just took place on the sun. And this material is actually traveling towards us. Now, our planet Earth has a magnetic field which is like a shield, like an umbrella that protects us from most of the solar winds. So, of course, there is a nonstop flood of sunlight that warms our planet, allowing us to live and see. But there are invisible connections, which are also equally profound, that is being showed in this movie. Solar radiation, puffs up our atmosphere with more energy, altering its structure and chemistry. Solar wind plunges into our magnetosphere and lighting up our polar skies with curtains of light, the auroras. And then it drives currents of electricity to the soil below. That really causes problem with our technology, with our power grid. Solar magnetism deflects the distant cosmic rays from those distant stars from interstellar space, moderating the effect of the galaxy on our tiny home in space. It's all about connectedness. That is what I see in my universe. Now you're seeing the picture of our planet Earth here. And anyone who has ever seen a picture of Earth taken from deep space, like an astronaut, can be forgiven for thinking of these two words: splendid isolation. Surrounded by millions of miles of this uninterrupted dark black, the fragile blue globe seems really profoundly alone, disconnected from anything else. But nothing could be further from the truth. Earth is profoundly connected to our star. The bright blue disk that we see from deep space is just the most obvious evidence. Now, did you know that we actually live in the outer atmosphere of our star? So the picture below shows the picture of an eclipse, where the disk of the sun is covered by moon's shadow, and you see the outer extension of sun's corona. And that is the outer atmosphere that is continuously blowing away and touching us here on our planet Earth to every distant corner of our solar system. Now, auroras are perhaps the most beautiful manifestations of a solar wind on Earth. When the solar wind gets past the magnetic field of Earth and travels towards inside our atmosphere, it runs into particles, right? And the protons and electrons from the solar wind hit the particles in Earth's atmosphere. They release energy of different color, sometimes green, sometimes, purple. And this is what is the cause of the northern and southern lights that we call auroras. Now, solar wind are dangerous too, also. In fact, now more than ever. And you're probably already guessing why already. And I'd say not only the living forces, even our technology is very much dependent on the sun's winds. Hundreds of years ago, technology was too primitive to be disturbed by space weather. Today, we rely on countless devices that are vulnerable to a solar storm. So think of all of the material you use that requires an electrical current, for example. Think of all the gadgets you have in your room, computers, televisions, cell phones, etc. Solar weather events have been occurring for millions of years, but they didn't directly affect humans until recently. Voltage fluctuations become quite commonplace during these times. Now, how do we feel space weather in everyday life? You have experienced space weather if you have flown on a commercial airline, for example, which we haven't done lately very much because of the entire world going through the pandemic, basically. But this happens especially in the polar routes where the magnetic field lines are open on Earth and particles can trickle in. And you could get, so for example, a person who travels a lot, like maybe 100,000 miles per year, could receive a dose equivalent of chest X-rays, which is, 10 times more than usual. Now, what the consequences of that are, we haven't studied as carefully because we don't have all the data. But there are countries where, for example, pilots and air crew are considered radiation workers. There have been extinction level threats to us in the past from some of these big storms. And one such storm was the Carrington event of 1859 that a British astronomer, Richard Carrington, was the first to see and document. But just in July 2012, Earth actually narrowly missed a storm. And we were able to kind of know that because we had spacecraft surrounding the sun. So this wasn't a storm that was directed at Earth, but one of our spacecraft actually experienced it and documented it. If the storm had hit Earth, we would still be picking up the pieces, said, one scientist. Another said that had it hit Earth, it probably would have been like the big one in 1859. The effect today on our modern technologies would have been tremendous. So we do experience this. These events, which happen every few decades or centuries, tend to dominate our consciousness in planning and our research portfolio. But also flare in Love and War, that's the one that creates, the intensity of this activity that creates all the harmful effects that we can feel. Now let's talk about outer space travel. I'm sure many of you are would-be astronauts, right? Well, it's funny, you don't even have to be an astronaut. We have just had 4 non-astronaut human beings that went to space and came back. We are going to travel regularly to outer space now. And we are truly on our way to becoming a spacefaring civilization. And one of the most deadly things that can hinder our progress up there, it's radiation from solar winds. So we have to understand and predict space weather right now. Now I'm going to show you this little movie that you can enjoy. This is describing how we are trying to address some of the space weather challenge questions by using the tools of artificial intelligence and machine learning, which is proving to be extremely useful when we pair them up with the vast amount of data we have. Okay, didn't want to complete it. It's a long movie, but wanted to give you a sense of what's going on in the world of also AI and ML. Now, thanks to a lot of the NASA, spacecraft like Stereo, like Solar Dynamics Observatory, NASA ISA SOHO, no major event on the sun goes without detection anymore, because we have spacecraft going to the far side of the sun also, and we can see the region of intense energy popping up on the far side of the sun and producing storms. Now, if you think about it, until recently, forecasters could scarcely predict space weather in the limited vicinity of Earth. Interplanetary forecasting was even more challenging, and this began to change with the launch, I would say, of Stereo spacecraft. Now, it's not just our planet, it's the entire solar system that lives with our star. You can see this, right? So this is the sun at the center. This is the corona. Here is planet Earth, and we are capturing these. These are real, images taken with stereo telescope, 5, contiguous telescope, kind of taking the breath of the solar wind, the solar atmosphere gradually escaping, right? So at the dawn of the space age, more than 50 years ago, protecting ourselves meant, protecting our assets on Earth. Now it means something much bigger. NASA and other agencies have sent probes to the far corners of the solar system, from Mercury to Pluto and beyond. And the Voyagers have left the solar system altogether. To protect these robotic assets and the humans that will inevitably follow them, as we are seeing, we must learn to predict space weather anywhere, anytime, throughout the solar system. Well, so we have just created sort of the ingredients, sort of for a approach to a brand new science. And we understood the importance of space weather and collaborated with fellow scientists to form this new branch of physics called heliophysics. And do you know what I call myself? A heliophysicsist, she who studies heliophysics. Well, what is heliophysics? Heliophysics is the study of the physical domain defined by the sun, the heliosphere, just like astrophysics is the study of the physical domain defined by stars. Very simple. The physical domain includes the sun itself, the solar system, and stretches out to the start of interstellar medium where the other stars begin to dominate. So in principle, heliophysics studies everything inside the sun's domain of influence. Heliophysics is also an environmental science. It is a unique hybrid between meteorology and astrophysics. So, I came and joined NASA headquarters after NASA Goddard in 1993, joined in 1998 when I became a bureaucrat. We're beginning to, manage and direct science program. And that's about 2 solar cycles ago, almost 22 years. A solar cycle is about, give or take, 11 years. And I measure my life in terms of solar system, right? Helps to keep me young in my own head. And through this time period, my entire journey has been fueled by my core love for the sun, taking me sort of in pursuit of understanding space weather and space climate and making everyone aware of the importance of heliophysics because it's a new science. It's the connected science. Today, I would say, having done this for over 20 years, studying heliophysics isn't a choice anymore. It's a necessity, just like we study climate, just like we study Earth weather. This is one of my proudest achievements, I would say, Living with the Star program, which, I managed for a long time. Now, Living with the Star program, what a beautiful name, first of all, and a program unlike anything before, I think. This was initiated in year 2000, and it was started to help astro and space physicists understand space weather better. And I was the lead program scientist for this pioneering program, which emphasized the importance of studying the influence of sun on our life and society. And one thing you have to remember here is society is not just on our planet Earth. Human society is wherever we choose to go. If we go to the moon, if we have satellites there, that's part of the extended society. Or if we go to Mars, or we send satellites to Mars. So think of it that way. SDO is the cornerstone mission, of course, Solar Dynamics Observatory for this program, which launched in 2010, and is about 11 years, one solar cycle old. It has really opened our eyes to new science and the connection between the sun and Earth, and by proxy, connection to other stars and also other planets. SDO is kind of looked upon as the Hubble for the sun, Hubble that sees all the other stars, but not the sun. But SDO looks at the sun in exquisite detail. And as if, sort of to memorialize that, the US Postal Service, actually USPS, released a forever stamps with a set of 20 stamps, depicting the various moods and fancies of the sun, as you can see in this picture. And I would say, when your science kind of comes down to a stamp in the post office, that is a really important moment in our ability to communicate our science to everyone. I can't imagine a better way of outreaching people and telling them about the sun. But of course, the mission, out of all the missions that is closest to my heart, is Parkour Solar Probe, a mission that is getting ready to touch the sun itself. Well, not completely, but very, very close, within 10 solar radii of the sun. It is already launched in 2018, and it is continuously getting closer and closer to the sun. It is 6.5 million miles of the sun's surface at this point, with a record speed of over 330,000 miles per hour. And Parkour Solar Probe is ushering us in the area of new science on the sun and solar wind. Well, a new science needs new scientists. Want to join us? Funded by NASA and managed by UCAR in Boulder, Colorado, the first Heliophysics summer school was started in July 2007. And you might even recognize few people there. 37 young scientists were instructed by 23 experts in topics ranging from practical techniques in supercomputing modeling to the fundamental physics of magnetic explosions. And since then, students from dozens of countries, over 500 of those, have been trained at this summer school. We have created 5 textbooks when we had none. I mean, a discipline must have textbooks. And then, really, the students with extraordinary promise often will apply for Jack Eddy Fellowship. Jack Eddy was a pioneering researcher in solar physics who shaped thinking about the sun-earth connection, sun-climate connection in the 20th century. So back to you and I again, son. The stereo spacecraft, Van Allen probe, Solar Dynamics Observatory, the Parkour Solar Probe, the European Solar Orbiter collaboration with NASA, a few of the major spacecraft which help in getting to know you, our sun, and sun-earth system better. The relationship between the sun and Earth was not all that clear before this. And in our pursuit of knowledge, we have now uncovered a much better understanding of space weather and its effects on Earth and other neighboring planets. And now I feel I know you, sun, and understand you a little bit better and can attempt to predict your whims and fancies with greater accuracy, just like we are doing right now, figuring out there is a M solar flare going on, how long it will take to come to Earth, what might it do when it arrives here. So, dear son, I think I know you better than ever before. That wouldn't be an exaggerated statement. So I hope you know me a little bit too, maybe. I'll be waiting for your answers. In the meantime, of course, there are important questions that were raised and realizations that have been arrived at. And these are some of those ponderings. We are transient beings, all of us. Since the universe resides within us, it is transient as well. Almost all of the cells in our body die within weeks to years and are replaced by new generations constantly. The human body and the universe in general is kind of like ocean and the beach. The cycles of continual ocean waves hitting the shore and really drawing away symbolize that decay and renewal as seen throughout the world around us in the biosphere, in the evolution of continents, and the lives of stars. And they could be human stars or they could be stars in the sky. The hierarchy of cycle makes the question, how old are you? Unanswerable. What are we really? Are we even the same from a minute ago? Much in our body is replaced, recycled, and in flux over our lifetime. Billions of cells die, each day, and roughly the same number are created in cycles that continue throughout life, processing all these elements coming from the ancient stars. So on a regular basis, stardust from the cosmos passes through us, forming successive generations of stars and planets in the same way as it does cells in our bodies, molding and remolding us over and over in that cycle. Where do we come from and where are we headed indeed? The question remains. Through life, death, hope and happiness, we try to divide ourselves far too much, not realizing we are inside, all of us, living stars processing star material. We are all living stars, and never forget that. Each one of us, have star power in us. We should use it. And I kind of want to end this talk, this is my last slide, by reciting a poem, a letter to the sun from the dark side of the moon. To my dearest love, my brilliant son, the world has decided we can no longer be one. So you take the day and I'll take the night. You with your happy glow, me with my cold and lonely light. It must be this way, always and forever. They say we can no longer share the sky together, but my nights will follow your brilliant days. I am right behind you, and I will love you always. So do not be sad, my love. Please do not fret, for my reason to rise is in watching you set. So never forget that. There was once a time when I truly was yours and you truly were mine, that there once was a moment I felt your lips. If ever you miss me, remember our eclipse. Thank you very much.
That was a terrific presentation. And I'm sure our students acquired a great deal of knowledge. And now, ma'am, allow us to take some questions from the students.
Sure.
Ma'am, here is the first question from Satyam. Ma'am, as you have said, heliophysics is becoming necessity to understand. But since most of the people don't know what to pursue, how someone possibly be sure of taking a branch which is new in study, although its concept was there with us since the long.
Very good question. You can pursue heliophysics by, you can start with just studying basic physics, astrophysics. Math is very important. Computer science, AI, ML tools are those are kind of becoming languages themselves. So they are on the side. But astrophysics, plasma physics, solar physics, ionospheric physics, you begin to branch, but the fundamentals are astrophysics, plasma physics, because you are studying the interaction between solar magnetic field with everything else. And that's the sort of fundamental difference between space weather and Earth weather. Earth weather is kind of governed by gravity, wind, things like that, right? Magnetic field doesn't play a part. Space weather is the magnetic energy, this invisible force that we can't even see, but that kind of control direct particles, their interaction. And we are fortunate on planet Earth to have a magnetosphere that actually protects our atmosphere inside. I don't know if this answers at least a little bit of your question.
Okay. And like there is another question from Nihar. What are the opportunities like internships, short duration projects under professionals like citizen scientist programs, etc., that NASA provides for aspiring international students, especially Indians?
Well, there are, I couldn't kind of give you the full summary of it, but there are many different kinds of programs, right? You don't have to be a heliophysicist. If you have the knowledge, you can pursue the same science on Mars or on Moon. It requires certain fundamental basis, like you need mathematical basis. So you need some core, science work that you have to do, but you can apply it. And so the reason I'm saying this is because there are many, many such opportunities. I cannot give you examples, but if you actually go to the NASA website, Google has become really amazing, right? You can find the various ways you as a young intern or you as an early graduate student can actually, and citizen science is becoming sort of core part of our program, right? So these are becoming very commonplace. If in my program, like the Heliophysics Summer School or the Eddy Fellowship, there have been, students from all over the world and many, many students from India.
And ma'am, there is a long question from Haripurna Chand. There's a multi-universe theory that says today in a video game, we control a place or a character. Maybe in a 50 years, we may create a game where we control a universe where there are humans living like us for them. And we are gods as we are gamers who is controlling them. So let's think it in reverse. Can we say that we are also a game which is being run by humans like us? Is a god is also a human like us because everything is running like a perfect computer program. So I want to hear your thoughts about this multi-universe theory.
Well, these are, it's fascinating. We all think this way. You heard my questions to the sun. Sun hasn't really answered my questions yet. The question sounds a little bit like the movie Matrix, where you think you are living in a simulation. And if you haven't seen that movie, I would suggest that the person who asked the question should see it. Do we know really for sure? What do we know for sure? I cannot answer that. But, we live in a world which is, so statistically speaking, I'm talking to you. I'm sitting in front of this table that's square in shape and it's really being pulled by gravity, right? The Newtonian concept of physics is still true. Does that mean Einsteinian theory doesn't work? Of course it does. Or how about the world of quantum that we don't understand very well? How are they connected? These are all still very important questions that we must, I would say, continue to pursue. So how would I answer such a question? Because they still remain my question. But I would say you are tethered to gravity. Probabilistically, you are here. Your wave function is very small, quantum mechanically speaking. So you are the person you are. When I see you, talk to you, enjoy the universe, we human beings sort of have this range of perception that is pretty much the same. If you know distribution function, there are tail end of the distribution function where people will think slightly differently. Our brains will perform different kind of thought process. But generally speaking, we live in a statistical world where we should feel pretty comfortable that things are okay, but never take anything for granted. It's a long answer.
Thank you, ma'am, for answering. And there's a question. Everyone has relations with our sun, some or other way. We have our own way to worship. What things one can learn from sun?
Well, I mean, there are scientific pursuits, which is what I talked about in terms of learning from the sun. But think of the spiritual pursuit, right? That many in India pursue. Think of Surya Namaskar, right? I mean, there are benefits to those. So I think the internet or Google or books, whether religious or scientific, are filled with such concepts. And we have to find our own individual way of interacting. My pursuit was to try to understand it, to see how far we can go with our science experimentation, to do the prediction that we are able to do. And I'm not doing this, of course, by myself. This is like the whole, academic world of scientists and engineers pursuing this. So I would say it's a very individualistic question. What we do philosophically and spiritually, I can hardly address.
Thank you. And let's take the final question. Do the sunspots and solar flares affect the magnetic field of Earth, as sunspot is a temporary phenomenon?
Yes, the connection is very interesting. So remember, when I was showing all these movies, ultimately it is the connection of the two magnetic fields, right? The magnetic field that the solar wind particles carry with them, with the magnetic field that the Earth generates. And if you should all know this, right? That magnetic field is very interesting, very mysterious. So the like poles repel each other, unlike poles attract each other. So the orientation of Earth's magnetic field has to be in the right way, or the solar magnetic field has to carry something where they can sync up when the unlike poles meet. Now, what happens during solar sunspot, when we get the sunspot number rising during this maximum phase of solar cycle that we call 11-year cycle, it really harbors a lot of energy, and that kind of manifests as active regions and then solar storms, and then they burst open, carrying material into space, and then interconnecting with our magnetosphere, which then changes essentially disturbs our magnetic field, and it compresses it, and it creates electric current the current that goes below. It trips, all kinds of circuitry, both in space and on ground. So that, in a nutshell, is kind of all and then there's many other. But that's sort of the connection that's going on with the magnetic field.
Thank you so much, ma'am. And this is the last and final question because the audience wanted to ask it. What life skills did you learn from NASA?
I think that you do not take anything for granted. You have to be dedicated in your pursuit, because money doesn't come easily. You have to convince people to give you money. All of these things, these are political, right? Getting resources is always a challenge. But if you keep your focus and continue to move things forward, NASA is a place where you can make the impossible possible. That's what I learned. That's why, I'm pretty old by Indian retirement age, but I'm still continuing to work because there are still so many different areas that we can pursue, especially in the world of artificial utilization of artificial intelligence, to learn new truth, new discoveries from the data we have already collected. And the other thing I would say is that I think being humble helps. Not be arrogant because you're a scientist, or some people will say you're a scientist at NASA. Well, it doesn't matter. You're still a human being and you're pursuing something. Someone else is pursuing something else. Keep your focus.
Thank you so much, ma'am. And I would like to ask a professor in charge, Vijay Kumar sir, to add his views.
Hello, namaste, madam.
Namaskar.
It's very grateful to hear from you. It is like it is proud for our institute as well as Axis team that you accepted our letter and give this talk. Your letter to the sun was very inspiring, and the thoughtful guidance you given to the students as well as the working possible opportunities at NASA. And the final thing you concluded with life skills. That is also a very, very great thing which will be helpful for all of us further progress in our life. Very, very thankful to you. Thank you so much.
You're welcome. Thank you. And I really want to kind of acknowledge, Kirtana, whose persistence made this happen. She kept her focus. She wouldn't let me go.
Okay.
So that's what's needed. There is, you have to have a passion, a dedication, and just don't take no for an answer. See where you go.
Thank you for those words, ma'am. And on behalf of the whole Axis team, I extend a sincere thank you to our Honorable Dr. Madhulika Guhathakurta, ma'am, for taking time out of her very busy schedule to grace the event. Your ideas have enlightened our minds. Today, we heard your views and perspectives, which will certainly inspire us in our lives. Thank you so much, ma'am, for gracing this event.
You're welcome.